In the previous topic, we learned about why there is an uncertainty in measurement and about accuracy and precision. If you've not looked, do check it out. In this topic, or in rather in this video, we are going to be learning about scientific notation. Avogadro's number is one of the most frequently used value or constant in our stoichiometric calculations. Would you like to know what it is? It is 6 0, sorry, write it neatly. Okay, it is 602 213 700 000 000 000 000 and I guess another 7 zeros. So 1 2 3 4. Yeah. So this is the Avogadro's constant. Imagine calculating your answer, doing stoichiometric calculation, where you have to write this number as it is. I mean, by the time we count the number of zeros and write them, we would have already made 2 errors by then and land up losing marks. Right. So what we decide, what had happened is they figured out, okay, fine, it's too tedious. So instead, there is something called as exponents which are used. So if we use the exponents, we automatically refer to it as the scientific notation. So this value consists of n into 10 to the power n. Okay, n into 10 to the power 10. N is the digit term or the number, whereas this tiny n is the exponent. Also, this n can be positive or it can be negative. So this n can either be positive or negative, and the exponent consists of two terms, the digit term and the exponent. So if for us to understand, okay, how does this work? Let's look at an example. So 1552.3. Generally remember, if we want to convert it to the scientific notation form, we just have one digit before the decimal point. The remaining is all going to be after. Okay, so I want to shift this over here, which means it goes here, and then it goes here, and then it goes here, which means it has gone from 1 to, it has shifted 3 places, and that has happened to the left. Okay, so it is moving left, which means it gets a positive sign. So this will be written as 1.5523 into 10 to the power 3, because we are multiplying this value to get this value, right? So if we multiply 10 into 10 to the power 3 is nothing but into 1000. So if we multiply it as 1000, it will again go to the right. So when we are denoting, we are changing the decimal point, if it is going to move left, the exponent will have a positive sign. On the other hand, if, let's take the example, 0.000257. Now again, over here also, you need to have one digit before the decimal number, and this digit should not be equal to 0. It should be a non-zero digit. Okay, so this decimal point will be moving here, and then it will move here, then it will move here, then it will move here, so that it comes here. Okay, so you're moving 1 2 3 4 places, and it is moving towards the right. And when it moves towards the right, the exponent automatically gets a negative value. So it will be 2.587 into 10 to the power minus 4, because this value is divided by 10 to the power minus 4, or rather, I'm sorry, is not divided by 10 to the power minus 4. I would like to clarify that. So it is divided by 2.587. This basically means divided by 10 into 10 into 10 into 10. Okay, so it will again, when you divide something, the decimal point will move to the left. To make things easy, you just remember this. When our decimal point is moving to the left, the exponent gets a positive value. Whereas when it is moving to the right, till there is a non-zero value before the decimal point, it is getting a negative value. Okay, so our Avogadro's constant, don't worry, we'll not be writing it like that. It is written as 6.023 into 10 to the power 23. Okay, this is what is used commonly in books and as a constant. Or if you want to see how it got the 23, you have 23 places before. So the decimal point is going to be moving from here to here, which is 23 places long, and since it's moving towards the left side, it gets a positive sign. Okay, so this scientific, we just can't finish this topic with understanding what a scientific notation is. We need to know how to manipulate these, right? Manipulate as in not cheat them, but to understand how to add, subtract, multiply and divide such notation. So we are going to start with addition first. Alright, so when you have to add or subtract, when you have to add or subtract in a scientific notation, the value of the n, so I'll just write the normal notation here, okay, scientific notation. So the value of this n should be the same. Only then we can add it. So the powers should be the same. To make things clearer, let's take an example. 6.65 into 10 to the power 4 plus 8.95 into 10 to the power 3. Now, here the value of n is 4 and here the value of n is 3. So, obviously, you cannot just say, okay, fine, let me just add 6.65 plus 8.95 and then let me just add 10 to the power 4 plus 10 to the power 3. That would make things wrong. So, you have to convert one of these powers to get n as equal for both. Generally, it's easier to convert the smaller power to the larger one. So when we have to convert 8.95 into 10 to the power 3 as 10 to the power 4, what we do is we will shift this decimal point to the left because it's a positive value. You're adding another positive value. So you will get it as 0.895 into 10 to the power 4. So this way we have made sure that the value of n is the same for both the terms. So then you just have to take the numbers common, 6.65 plus 0.895 into 10 to the power 4. Okay, and once you add this, you will have the answer as 7.545 into 10 to the power 4. So what we've done, we've basically ensured that the value of n is same for both these terms. Generally, we convert the smaller one to the bigger and then we've added it. Simple, right? So let's take another example. In case you haven't understood, let's do another one. Okay, here we are going to be subtracting. We're not going to be adding, we're going to be subtracting two terms. For example, 6.65 into 10 to the power 4 minus 8.95 into 10 to the power 3. Okay, so this is same as the example before. Only thing I've done over here is change the sign, just so you can understand. So here again, you will be changing the value of 8.95 into 10 to the power 3 to get us 10 to the power 4 to 0.895 into 10 to the power 4 6.65 into 10 to the power 4. So when you subtract, you can take it out as common. 6.65 into 0.895 into 10, sorry, minus into 10 to the power 4. So this gives us the value as 5.755 into 10 to the power 4. So here we've subtracted, we've taken the same values as before, and we've converted this to give us this. So this is to ensure that 10 to the power 4 can be taken out as a common factor. Another example is 2.5 into 10 to the power minus 2 minus 4.8 into 10 to the power minus 3. Here we have a negative sign on our as our n, in front of our n, the value of n. Because of the negative sign, this value is obviously going to be higher than this one. So this has to be converted to this. And how do we do that? So let's take 4.8 into 10 to the power minus 3. If I want this to become minus 2, we need to add it by 1. And if we want a positive sign, it means that the value, the decimal point, has to move to the left, because left is going to be positive, right? So 0.48 into 10 to the power minus 2, because minus 3 plus 1 gives rise to minus 2. So we are converting this to get this. Okay, so again you can easily subtract into 10 to the power minus 2 minus this value. Okay, and that's equal to 2.5 minus 0.48 into 10 to the power minus 2. That is equal to 2.02 into 10 to the power minus 2. So the difference between the previous two examples and this one is the fact that the n has a negative sign beside it. Here we've converted a minus 3 to a minus 2. Now suppose, let's take another example. Suppose I'm just going to show you the conversion. So if we had to convert 2.5 into 10 to the power minus 2 as 10 to the power minus 3, in that case we would have had to shift the decimal point to the right, because here we want it to be one value more, right? So here it has to be minus 1, minus 2, minus 1. I'm sure you would have learned the basics of addition and subtraction of integers. So minus 2 minus 1 gives rise to minus 3. Okay, so here you had minus 3 plus 1 will give rise to minus 2. So this plus 1 made sure that our value moved to the left. But since it is a minus, so it has to move to the right. So we would have gotten 25 into 10 to the power minus 3. And then we would have done for with the calculation or conversion. So that's about addition or subtraction of the scientific notation. The next is going to be division and multiplication. Division and multiplication is actually pretty easier. So division and multiplication. So let's start with multiplication. It's always easy. Okay, so let's assume you have two values, 10 to the power x into 10 to the power y. When you have to multiply these two, you will write it as 10 to the power x plus y. That's it. You just add the powers. So first example we're taking is 5.6 into 10 to the power 5 into 6.9 into 10 to the power 8. So here you have 10 to the power 5 as 10 to the power x, 10 to the power 8 as 10 to the power y. So 5.6 into 6.9. I mean, that's just the numbers, right? So, and this into 10 to the power 5 plus 8. So when we calculate 5.6 into 6.9, it gives us a value of 38.64 into 10 to the power 13. But when we are denoting it in a scientific notation, we should have only one digit before the decimal. So we are going to shift the decimal point to the left, and when it shifts to the left, we will add plus 1. So 3.864 into 10 to the power 14. So when you have multiplication taking place, you are going to take the powers and then add them. And the digits are going to be multiplied as it is. Then let's take another example. 9.8 into 10 to the power minus 2 into 2.5 into 10 to the power minus 6. So 9.8 into 2.5, I'm taking those out separately. Okay, and 10 to the power minus 2 plus minus 6. And as we know, minus into plus is minus. So minus 6 and minus 2 will add up to give us 10 to the power minus 8. And this value, when you calculate it, you will get it as 24.50. And since we should have only one non-zero digit before our decimal point, we are shifting this over here. And when we are shifting it this side, it means it will have a value of plus 1 over here. So here when you add plus 1, it becomes 22.450 into 10 to the power minus 7. So here we've taken two examples, one where both powers are positive, you just add them. One where both powers are negative. Again, over here, because both of them have a negative sign, you will just add them. Now we're obviously going to take a third example where one of the powers is going to be positive and the other is going to be negative. So 3.025 into 10 to the power 3 into 6.217 into 10 to the power minus 6. So here you have this power as positive, this is negative. So 3.025 into 6.217 is being taken out as a common, not common, I'm sorry. We're taking them out as numbers. So this is at the side and this is multiplied in 10 to the power 3 plus minus 6. So again, minus into plus is minus. So minus 6 plus 3, which means that this will give us the value of 10 to the power minus 3. And when you calculate this, you will get the value of 18.81. So when we, again, here also we shouldn't be having a two non-zero digits before our decimal. So we will be shifting it here, which means it will have a plus 1. So 1.881 into 10 to the power minus 2. So these are the three cases. You will have either both as positive powers, then you just add them. Both are negative. Again, here also you will add them. But when you have one as positive and one as negative, you will be subtracting them because of this particular place. Okay, but generally you need to remember 10 to the power x into 10 to the power y gives rise to 10 to the power x plus y. In division, or rather when we divide, scientific notation, 10 to the power x divided by 10 to the power y will be equal to 10 to the power x minus y. Okay, so 10 to the power x by 10 to the power y will be equal to 10 to the power x minus y. So let's take examples again. 2.7 into 10 to the power minus 3. Also, I forgot to tell you this. If you would like to, you can pause the video while I'm solving and try solving it on your own. And, just check if you're doing it right or wrong. So 2.7 into 10 to the power minus 3 divided by 5.5 into 10 to the power 4. Okay, so let's take out these numerical values. 2.7 by 5.5 out. Okay, and 10 to the power minus 3 minus 4. Okay, so because 4 has a positive value, we will be deducting it with, so minus 3 minus 4, which means 4 plus 3, minus 3 minus 4, since they have the same sign, they'll be added, 7. So 10 to the power minus 7 into 0. When we calculate this value, we get 0.4909. Now, as I told you, scientific notation is supposed to have at least one non-zero digit before its decimal point. So we are going to be shifting it from here to here. And because we've shifted it towards the right, we have to deduct 1. Okay, so here you will get it as 4.909 into 10 to the power minus 7 minus 1 will be minus 8. So here we've basically taken this to the top. So we follow the rule 10 to the power x minus y. So 10 to the power x minus y. Let's take another example. 4.74 into 10 to the power 12 divided by 6.82 into 10 to the power 20. Okay, so 4.74 by 82 into 10 to the power 12 minus 20. Let me do one thing. Let me write it below it. So into 10 to the power 12 minus 20. So when we calculate the value for 4.74 divided by 6.82, you get 0.695 into this minus this is 10 to the power minus 8. So when we shift this value, again because it's non-zero digit, we shift it to the right, minus 1. So you have it as minus 8, right? So minus 8 minus 1 is minus 9. So 6.95 into 10 to the power minus 9. With that, we conclude scientific notation. In this video, we had studied about what a scientific notation is. It has two forms, two parts, not forms, rather two digits, the n and this n. So this n denotes the digit, whereas this n denotes the exponent. We always should have one non-zero digit before the decimal point in this n. Whereas a small n can either be positive or negative. It gets a positive value when the decimal point is moved to the left and gets a negative value when it moves to the right. Then we learned about how you can add and subtract and divide and multiply the scientific notation. When it comes to addition, you need to make sure that the n value for both addition and subtraction, the n value is same for both the quantities that you are adding or subtracting. Whereas multiplication is 10 to the power x into 10 to the power y will give rise to 10 to the power x plus y. Here we are just adding the powers, whereas in division we will be subtracting the powers. The next topic we are going to be studying about significant figures, which is again a very important topic. So do check it out.